So this will be like, so Rails scales. It does. I've done it. But it doesn't do it out of the box. If you just throw Rails out there and into the wild, your website will stop working very quickly. It doesn't do a lot of things that I'll talk about. So first and fact, we do 11,000 requests a second. We don't actually do that. We might have at some point. We didn't have numbers when we might have been doing it. I can reliably say that we do 600 requests a second. We have 180 Rails instances running in Mongrel, and we're adding to that fairly quickly. We have one database server. We have not done any partitioning. We do reads to a read-only slave for statistics like reporting and so on. We have 30 other processes for just things that we'll talk about later on. It's all some X4100s I'm throwing in, and we have a lot of users and a lot of updates. I won't tell you how many, unfortunately. This is what we've been doing. It's a lot. March was difficult. So these are the blog posts, and as you can see, it's not slowing down. I mean, I looked at this graph, and I remember the curve was up at the beginning of March, and I have physical reactions to that curve. And it's more now, which is scary. And I think Time just published an article in the print edition, and there's like some new kind of stuff and whatnot. Rails hasn't scaled for us, in large part because getting servers has been really difficult. So just like Sun has supply problems, and getting them in place has been really difficult. So that's been a big problem for us. It's great for application horizontally scaled. It doesn't work if you don't have a service. So that's mostly resolved now, and we're a lot faster now. So this is sort of our growth curve as perceived by the developers and the people who work on Twitter. Yeah, I mean, it's been hard, but it's been really rewarding, and it's working out. You can see that the pain curve is going down, and so that means that it's scaling. You know, we're in your rails, go fast. And you know, I've got some slides later, but we do basically uncached requests in less than 200 milliseconds a lot of the time. So on Rails, with all the fancy binders and all that kind of stuff, so it works out all. It's easy, in fact. Step 1, realize your site is slow. Step 2, optimize the database. 3, cache the hell out of everything. That's elegant. Forward scale messaging, and that's something that I suspect a lot of people haven't dealt with. It's not a usual web app thing to do, and so I'll talk about that a little bit later. And then dealing with abuse. I haven't seen a lot of talking about dealing with abuse in terms of scaling, but I mean that's been one of our big problems. And the profit, of course. So, the more you know, the better off you'll be. We failed completely at this. We had no statistics, no graphs, no server level graphs, nothing. It was awful. It was horrible. It was better than that. Don't be like us. Have an access. These things are easy to set up. We ran into some issues with Solaris and so on. I mean, these are Linux tools for a Linux team and Solaris. And it was difficult to have those in place. We had Google Analytics, but Google Analytics doesn't get you anything when your pages aren't loading. AW Stats is fantastic because for any sort of log processing, we have a little snippet of code that we create combined logs from the Rails log and actually log it to a separate file so that you can, we don't have a web server in front, we just have a load balancer. And so we don't actually get combined logs. So that is phenomenal, and it works really well.
Can you hold the microphone closer?
Sure. Is that better? Okay, better. Use the exception notifier in the loggers. It sucks to get 7,000 emails in your inbox in the morning, but it's really useful. We've moved to the exception logger, which gives you like a pretty neat interface and everything, so that we don't get those emails. Gmail doesn't stop giving us email. And when you do have problems, if there's a new system that's failing or something, add reporting right now. Not later, because it will save you time. Test everything. In preparing these, I got some questions like, well, what does testing have to do with scalability? Well, if you have some limited set of tests and you start adding caching on the fly because the site is down, you want to be able to deploy that and know that your cache pages are going to render properly and not show random crap. I think that there's a quote somewhere out there that the biggest sin is showing users the wrong data or old data or whatnot. So that's been super helpful for us. We have a full suite of tests, and when we added caching, stuff broke, and that was fantastic because we were able to fix it before it got deployed live. Benchmarks. We haven't done any profiling. I have hundreds of thousands of users and millions of requests a day to do all the profiling I need. And we have some tools that we're working on that basically A/B testing, but we're looking at using them to actually get performance data, so we can push changes live and get a better sense of how the site is performing. The slogan, by the way, is Ev's page. He's got 2,000 or 3,000 friends. That was going to be hard to speed up. So getting into the database, and speaking of speeding up things. So we have Stuart here. He built Flickr. And I heard a rumor that he came into the office recently, kind of moaning and saying, the next application I'm going to build is going to be easily partitionable. And that's fantastic. I mean, if you can build an application that's easily partitionable, do it. It's way easier. Flickr isn't, Twitter isn't, I don't know if you can see it there. Those are the friends and followers counts. Social applications you can't easily partition. These people have, 3,500 friends, and there's 100 of them. And trying to do anything with that is a real challenge. WordPress, anything that 37 Signals builds, all of these applications are, you have a bunch of silos that you can put people into, and you're essentially just running a bunch of apps rather than one app that you have to scale. So you can scale each one of them individually. Once you've decided that it's too late and you can't partition it, you index everything, and you should do this no matter what. Rails will do it for you. It's easy to do. Use explain so that you can analyze the queries, and this is all standard stuff, right? But it makes a huge difference. There was one index we added 3 or 4 days ago where the invitations, there were people were trying to invite other phone numbers. So with Twitter you can kind of say add phone number, and it'll add that person and send them an invite and so on. They were coming through as integers, and MySQL wasn't doing the index matching on it, and so they were piling up in the database and slowing everything down because it was an integer instead of a string. And it's like, we don't get that many invitation queries, but it was making a difference. And so they had changing it to use a string index a ton. Denormalize. Denormalize. This might be heresy in the Rails world. I hope not. this is single-handedly what saved us more than anything. So we have things like this, where we have a friends_IDs column on the users channel, and we denormalize into it. And so we have a has-many relationship to a user's friends, and we just throw all of the integers in here. It's really easy to do. There's basically all the code. It's not everything. It's a mock-up. But basically, you add a friend and you stick it in this counter. When you remove a friend, you delete it with this return. It means that you can do inquiries, and those inquiries against primary IDs are going to be very, very fast. And it's been pretty successful. I think we actually don't do any caching of individual active record objects. We load everything, but the queries that we use are fast enough that it hasn't quite become a problem yet. Don't be stupid. You'd be surprised. I surprise myself all the time. Don't do things like this. So, bob.friends.map works great when Bob has 4 friends. When Bob has 3,000 friends, it takes down the server. Because Active Record tries to load, 4 gigabytes of friends into memory and then iterate through them. Status count works great when it means 100 statuses. This is NVB, minus NVB fast. But you're using NVB, right? Status count when there's millions of rows stops working, and everything just slows down and you're set behind time to go. The last one should be self-explanatory. We were doing that until fairly recently, and that's why we don't have search right now. So these are the database things that we've done. That's it. There's no surprises. So there's been a lot of discussion about partitioning stuff and whatnot. That's great, we'll do that. But this is all we've done. And our database, we're so not locked on our database. The average database time is 50 milliseconds, 100 milliseconds, something like that. We're not hurting there. And I think we're at about a quarter CPU utilization on one master database machine. So the only case that you would be doing partitioning at this point is if you built an application that's easily partitionable, i.e. the first rule of Butterfield, which you should really consider if you're building a map. And partitioning will come later. We'll have to do it at some point, but we're not thinking about that right now. We'll let you know. One of just to sort of follow up on some of the conversations that have been happening, the reason that partition isn't easy for us is simply that there's all sorts of automatic memoization that happens, and so we can't guarantee that read-only operations are going to be read-only. And it turns out it's actually more difficult than it would first seem to guarantee that when you hit that read-only slave, that you're not writing to that read-only slave. And if you write to that read-only slave, you're screwed. So you have to be really careful with those sorts of things. Next part is the cache. So we do a lot of caching. We use memcache. We use memcache. We use memcache a lot. Do it. So we do things like I mentioned earlier that status count stops working. Well, if you want to get a list of if that's something that you need, you can just memoize it into a memcache accessor, and you get it, and it takes a millisecond or something, or less than a millisecond to get, and then less than a millisecond to set, and then you can just increment and decrement it. So this one's a global one. You can do this for whatever you want. We store. So this is everyone more or less familiar with it? I probably should have asked that at the beginning. So with Twitter, the application. So when you view your friends list, you get, I won't switch. but you have a list of all of your friends' statuses, so you can see what all of your friends are doing. And that query is really difficult because basically you're doing this going where you're saying, show me all of the statuses that belong to any of my friends that were created in the last 24 hours and that I'm allowed to see. And then you have more complicated queries where you're saying, like, show me my friends' friends and all these sorts of things. And the security and privacy issues abound. So what we do is we have this, it's just it's an array, fixed link that's 20 items, and that's why there's 20 statuses on your homepage. And every time one of your friends updates, so this status created here, every time one of your friends updates, we just stick the ID of their status into this array and do a select on it, so that we can just do a single select statuses where status IDs are in your friend's statuses, and that's it. And so it's this very, very simple, highly optimized query, and it's this thing that we've kind of custom built, and it all sits in memory and it's accessible to all of the servers, and we never touch the database for it. And in fact, the long term is to actually store each of the statuses in memcache as well. So what you end up doing is you say, okay, well, what are the IDs of the statuses, and then you fetch them individually from memcache, and you end up with a predictable time frame. So you can say, I know that I can get all of the statuses for this person in 20 milliseconds, and that's the upper bound on it, unless something is horribly wrong with your network. In the future, we've started prototyping this. I don't think it'll come in a fancy box, but active record objects are huge, and so it's one of the reasons that we haven't stuck them in memcache yet, to serialize and deserialize some of these objects, especially if associations get loaded on them, can take a long time, and it's a lot of memory and it's a big waste. So what we're looking at doing is actually implementing. If anyone wants to do this and test it, please do it first. Please do. So we just store it in cache, just the critical attributes that we need to display, like to render it, and then add a method missing on the hash that says, well, if you don't have that attribute in memory, go and load the active record object and pass it through. So it's a super trivial idea, but I think it's the only way that we're going to be able to cache active record objects in memory. 90% of our requests are API requests, and they're relatively the same. With the web, there's a whole bunch of like customization and fragment caching is a disaster. Rewriting fragments is horrible and it's non-deterministic. So we don't do any fragment caching or any page caching, in fact, on the front end. But in terms of the API requests, because there's no rewriting we have to do, we can just cache them, and it works great. And it's a before filter and an after filter. So there's quotes like this quote that there's only two hard things: naming and caching validation, which brings us to messaging. So you already knew all that other stuff. You've done it all. It's all, there's lots of documentation on it. There's at least 4 or 5 talks on doing this sort of scale with Rails alone, and then you can get into, Cal has a book on it, and there's Schlossnagel has a book on it, and so we use messages a lot, and you have producers who produce messages, and you have a queue, you have consumers who consume messages. And so we do this for caching validation. So we'll create a message to invalidate the cache, because when you have 3,000 friends doing 3,000 caching validations, it is fast on an individual level, but that takes 3 seconds with memcache. And so you can't do that on web requests. So we create a message saying, hey, go invalidate this person's friend's caches, and then a deferred worker will do it, and it takes 3 seconds, so that's not the case. stuff, but it means that we can return the page quickly to the user. So we started out using DRB. It's great. I love it. It's stupid easy. It's I have a slide here coming up that's how stupid easy it is. I mean, that's it. You get a shared object at the end of that, so you have a server that just runs in a persistent thread, and then the client can sit on another machine, and you get an object, and it's that object. It just works. It's reasonably fast. It's kind of slow, actually, but but it doesn't matter. I mean, we do less than 100 messages a second. It's a lot of messages, but you can do a lot of messages if you're doing less than 100 messages a second over, you can do it. It's fine. We do it. That is kind of flaky. There's not a lot of redundancy, and it's tightly coupled. So, I mean, the solutions, none of them are super great. And the problem is if you've got one DRB handle, that goes away. You have to have this whole failover mechanism, and that's complicated and irritating. So this is sort of what we started out with. This is just the Jabber component. So we've got eJabber, and then we've got a Jabber client in Ruby that connects to it, and that exposed a DRB handle, and it had some keys and so on, but basically it pushed out presences. And incoming messages, so that's, so-and-so is online, so-and-so sent you a message. And then some workers pushed outgoing messages to the Java client, and most of the coordination was done through MySQL. And then we moved to Rinda, because that kind of got too flaky, and so when the Java client went down, everything went down. And it was a really big end. So Rinda is a shared queue. It does multicast out to the network, and it says, hey, I'm here. So you can have a local network, and all of the computers can instantly see this ring server, essentially. It's on DRB, so you get the same method, calling magic. The Seattle Ruby folks have done some really cool stuff. Ring Dingy is one of them. It sounds kind of janky, and it kind of is. But it works, so it's just a couple lines of code to get access to the shared queue. I put out a bunch of documentation on this stuff. It's a good place to start. It's open for take, so that means that when the queue gets backed up and you have 70,000 messages in the queue, you shut down Rinda, you lose all of those messages, and you start it back up again because it will never catch up. Someone made a comment at some point asking whether Twitter was TCP or UDP. It's definitely UDP. I won't share any numbers, but it's definitely UDP. This is our queuing mechanism until very recently. That's the subversion commit message above there. It works. We had 10 processes that processed messages, and it was fine. It's a property of decimal integers that they go from 0 to 9, so you can kind of split them up that way. Yeah. Stopped on Tuesday. It just stopped, and all messages stopped in the middle of the Web2 Expo. I didn't go to any sessions. So we have some options. There's ActiveMQ, which is in Java. That's full stack. I mean, you can do, it's fast, it's stable, it does all sorts of fancy, non-twiddly things. So you have like the main server, and that's in Java, that talks Stomp and some other open wire format. And you can send messages to it, you can receive messages from it, and it'll store the message. The message is transactional, so the server can go down, and it'll still catch up. Like you won't lose the messages like you did with Rinda. It's too much of a platform. It was too heavy. It was a lot. RabbitMQ looks really promising. There were no Ruby clients for it, and I wasn't going to write one on Wednesday. you can use MySQL with some more lightweight logging. This is what LiveJournal does. They have a horizontally scaled MySQL cluster, so they can have more than 10 processors, and that works all right for them. Or you could use something else. So we could rewrite the site in Erlang. There's been some discussion of that. But I'm not excited about that. I think that the best way to explain that is, has anyone here had to get a broken Erlang server to start up on a Sunday morning with 20,000 users? Service being down, put this down. I've done it. It's not fun. There's not a lot of documentation. There's not a lot of community. I went on the developers list and asked, how do I get this thing to start? And the developer's response was, I don't know. It's fantastic. I love Erlang. I love the concepts. It's not for this sort of production. We're doing some experiments with it, but I'm afraid of throwing it into production. It's ugly. So I wrote Starlet, the Erlang one that starts Starlet. So it's in Ruby. It's like 200 lines of code, mostly based off of Mongrel. So I just extracted the network portions of Mongrel. It does 4,000 transactional messages a second in pure Ruby. It writes all of the messages to disk as they come in, and as they go out, it writes a thing saying, oh, I sent out a message. And so you can have multiple queues, and so like we have a cache invalidation queue, for example, or an outgoing Java message queue, or a incoming AIM message queue. And so there's all these queues and all this sort of thing. And it speaks memcache. So you have clients in every single language. You're done. And we put it in production on Wednesday, and it's been working. It hasn't gone down. It's been working fine. And so this is sort of, this does what the task scheduling part of Erlang is supposed to do. So you have a bunch of processes that sit out on your machines, and this passes messages to them and says, hey, go do this work. It works great. We'll probably be releasing that as open source. I can't say yes for sure because I don't have the official. And then you just use messages to invalidate the cache. It's not that difficult. We do it. It works for us. We add new cache things all the time, and it's really easy to sort of add invalidation. Granted, our system is a message-based system, so it might be harder to map the metaphor. Dealing with abuse is sort of the last part. In January, we had this issue with Italians. I don't know anyone who was a user on Twitter at that time probably remembers. There were all these people coming on, and I think you can see it there. 509 friends with 96 followers, 160 friends with 22 followers, 88 friends with 15, and so forth. And so these people were going on and friending everyone on the site. And I think this is a big problem because our system wasn't optimized for this many friends, and there were lots of them doing it, and it was costing us thousands of dollars, which doesn't help the server acquisition part of things. So what we found out was that in Italy there are carriers that give you free top-up on your phone plan if you receive so many messages, and so they were inverse spamming themselves. Spam is not the problem on Twitter, but inverse spam has. But shutting that down was important. This last week, a lot of our downtime this week was, people crawling the site and adding everyone on the site as friends. And when you start getting people with 9,000 or 10,000 friends, it starts taking the site offline because there's just so many new things that you're doing that it destroys things. And so the trick is just to be ruthless and just say, no, this is taking down the site, delete, you're no longer a user on the site. And it helps to have reporting tools and tools to really have a better understanding of what's going on and be able to be able to react to abuse, and be able to detect abuse as well, because sometimes it's not obvious, and you'll spend a bunch of time tracking down a problem with the code somewhere, when really you can just delete one person and your site's fast again. So it's sort of frightening. And that's really it. It's the photos I use. I wanted to open up the floor to questions, because I think there will be some. So yeah.
Yeah, I was curious, what did you mean that fragment caching was a disaster? And why don't you do page caching at all? Like, what's the thing kind of?
So, let me, just by way of example, it's probably easiest to do that.
Can you repeat the question?
Oh, sorry. So the question was, why didn't we do page caching, and why didn't we do fragment caching? Like, why did we see it as a disaster? So when you look at the page here, so these are my friends, and up here is a bar that's personalized for me, and this stuff is personalized for me. And here it says this message was sent 20 minutes ago, and this one was sent 30 minutes ago, and these times change as time progresses. And so if you're going to cache that as a fragment because it's viewed on a bunch of different people's pages, well, that's fine, but you have to rewrite it, so you have to change the time that it says there. And there are tools to do this, this extended fragment cache stuff. Doesn't work. We made 3 or 4 attempts to make it work, and it was largely non-deterministic in terms of actually getting it to display the right content. And so we decided that it wasn't that big of a win, and went after bigger fish, so to speak. So that's, and then, I mean, the page caching is just it's a more abstract version